So we talked about files, we talked about table formats. What's the difference? What is it, right? So on the left side, we have file format. Most of you are probably familiar with what Parquet, Avro, CSV, JSON are. The objective of these file formats, particularly Parquet and Avro, is reducing the storage size. So how can I compress and optimize the data the best way possible? So I'm storing as little amount of data as possible. So I'm saving you on storage. The second piece is optimizing read performance. Now that I store the data, how can I speed up the ability of a query engine to pull that data back out and return it back to the user as quickly as possible? And comes along with it is, how do I minimize data scan? Like, I want to skip the parts of the file that are not relevant to my query, and I then want to return that data as fast as possible. So minimizing data scan also reduces your cost. And then many times it's either a columnar-based format or row-based format, depending on your use case. On the right side is a table format. So a table format is actually built on top of a file format. It's a specification that defines how to manage schema and how to manage these large data sets in a coherent way. So its purpose, its objective is to optimize schema evolution, to make it easier for you to evolve your schema. It allows you to kind of define multiple access patterns. So if you're trying to query a data set, let's say security logs, and you typically want to filter based on date, but there's a new use case where you really want to filter based on, some specific device type. Well, if you didn't partition that data properly on your data lake, you can't change that, right? It's very static on a data lake. But in Lakehouse table format, because it's all managed through the metadata, it's really easy for you to change that and optimize it. So you can support multiple access patterns very easily. It also helps accelerate query planning. So as your query engine goes to run a query, it needs to understand, where does the data live? How big are the files? What rows exist in what file? Are they sorted? Are they not sorted? All that information needs to be gleaned from the physical files inside of a data lake. But using a table format like Iceberg, that information is actually encoded in the metadata. So you go to the metadata and you say, hey, I want to query this table. It has, hundreds of thousands of files. I want you to give me an idea of what files I need, where do I find them, and what's the best way to get to them. So this metadata layer is kind of like a map, like a way for you to find your way and then ignore the things that you don't care about. So it's really, really powerful in speeding up the query planning. And then, of course, as I said before, it also supports transactions, right? Because that's more of a metadata operations, right? Here's one table, it's a snapshot. When I'm done changing it, I'm going to commit that. And another writer can pick up another snapshot, change it, and then commit that, and then we kind of move forward. So that's the difference between a file format and a table format. But again, table format rides on top of a file format.